Hi Rahul, hi Rohit, and everyone. How
Hi,
you-
Aravind. How you doing?
Yeah, I'm good. I'm good. Thanks for asking. And
Yeah,
I wish everyone had a great time, like for the first talk. Uh,
yeah.
and yeah,
Like we are running a bit late, I guess, because of the Q&A and
no
Kamesh really
worries.
had a really great session and it was a bit lengthy, so that's why. So maybe we can quickly start off with your session. So you can
Sure.
introduce about yourself and what is the session is going to be. And
Uh,
yeah,
I just don't want to like you can if you can add my okay I'll
screen.
tell about myself and then like we can get started. So today this session is more about the running Elasticsearch on Kubernetes, more not just Elasticsearch but more about running Elastic Stack, the whole stack in an orchestrated much better manner. And I thanks Kamesh for doing the Kubernetes session before, because it helps people set some context and also like drives them in the same thought. And whatever I'm going to show today is not specific to any cloud platform, etc. You can use this in any other cloud platform as well. And then you could also apply some changes and do your own stuff. So as you could see, I think, yeah, the screen is pretty small. Let me zoom it a bit. So I have the Kubernetes, I mean Azure Kubernetes, the home screen here, and then what I want to do is like create a Kubernetes cluster before we get into the topic, and then when we come back, or when we are good and we are clear, so we can simply get started with the demo actually. So that just in saving time for the time being. But also this will be very demo oriented. So if you are thinking that okay, the last session was demo, yes, this would also be really fast in demo as well. I mean, like next time I should ask Rohit to like give more time to everyone. So let us quickly create this one, CC days demo. Great. Asia Pacific, the version of Kubernetes. I'm just creating on this one. This can be created on anyone, any I meant to say system actually, cloud provider or even OpenShift kind of Kubernetes service as well, or your plain vanilla Kubernetes or your Minikube K3s, anything. Whatever we are going to talk about, we're talking about something like operator, which again, like Kamesh mentioned, and I'm disabling some stuff like service principal, system assigned managing. I mean, like I'm changing some things because just this is for demo. So and I just want everything to be right, and network configuration to be same, DNS, private cluster, disabled network policy, and HTTP application routing. All of this has been like disabled and said no. And then we'll quickly go to the integrations. Container registry, no, I'm not integrating with any. I'm not going to deploy anything from outside like a container, so I'm not doing that. Log analytics workspace. So what we'll do is like we'll not do container monitoring because it will take a bit more time to spin up. So meanwhile, if we come back, we can quickly like do something. Oh, something went wrong. So maybe that is because my resolution, and I have missed something definitely. So in the basics, I missed something. Okay, yeah, see. So great. So maximum node count data is select is 2. Okay, I could select something. So I already have a cluster running already, and then that might be a reason to do this thing actually. So what I'll do, I can also show you this one, but also like I can create something new. So let me see two, and then let me kind of like, but still use the same high quality, the hardware. So hardware is very important when you choose something like Kubernetes is a platform, so you should not do that. So let me quickly go back, review, and hopefully it should create now because it's all done. Once we click create, we'll go to the presentation, we'll see a bit of slides, and then we'll come back, and then we'll again see some more of demo, and then like some information, and then I'll leave you more with more and more details. So I have a packed agenda, so that like we are running on time. So so again, like today we are going to talk about Elasticsearch on Kubernetes, and how do you build, how do you use that. Remember, it is not Elasticsearch, it's Elastic Stack. The reason why and everything I'll explain. So I'm Aravind. I work at Elastic as a developer advocate. I run the open source communities in India, Southeast Asia, do a lot of things. Everything developer community. So if you have any other question related to any other technology, also feel free to ask. Maybe because I work with various sorts of things. So happy to help being a developer. So that's about me. And you have my blog and my Twitter if you want to DM me after the session if you have any specific questions. That being said, what do you get in this session? I've been talking about many things, but then deploying the stack on Kubernetes. That's the major thing that you get here. Between, I keep saying what is stack. So, but what is Elastic Stack? So, a bunch of components which makes this particular stack. People call it as ELK, like if you see the name here, but actually it's more than that. It has become more than that over a period of time. After I have joined, I think we have added 2 or 3 products. So it's quite interesting that it's like a developer stack, and then you can build, orchestrate, do solutions on top of it. And again, everything is free and open. So you could simply do that. So Elasticsearch is a distributed NoSQL data store. Kibana, as you know, is a visualizer which sits on top of Elasticsearch, which does data analytics and a bunch of stuff. Logstash and Beats are the ingestion modules which pushes data into Elasticsearch. And so this included fully, it's called Elasticsearch and represented in this below small bar. But at the same point of time, you might see that there are multiple things here, like say multiple solutions that are developed on top of Elastic Stack, like say search, being Elasticsearch being a search engine. People do search engines on top of Elasticsearch. There are so many search bars that you see in India, specifically Indian startup ecosystem, and large companies like Cisco, etc., are really powered by Elasticsearch. And then like you also have something like observability, you have security, multiple other things to help different developers, developer personas, like say whether you are a developer, whether you are like app dev, or whether you are a DevOps person who's helping monitoring, doing a lot of that, whether you are InfoSec security data practitioner, or whether you are a supervisor or a product owner who is looking to make sure that the things get delivered in time and your application is delivering, the certain amount of 8 millisecond the page should load, or like these are the things, metrics that you want to monitor, like be a product manager or supervisor or anyone. So multiple user personas, more than this. Maybe I just summarized into 2 or 3 people, but there are more people who use it in different formats. So popular way to deploy Elastic Stack is like, obviously you have cloud platforms, you have your own on-prem data centers, people use everything to do everything. But at the same point of time, I definitely want to mention that we are partners with all of these cloud platforms, and like you could deploy the same sort of the enterprise or the paid version on your clouds, just by using your regular cloud credits. So this is something that is not mentioned more often. Just want to make a mention. So you don't need to build it like on EC2s or like Azure VMs or compute engines, or you could use that and still leverage like a managed service. But then today we are going to talk about Elastic Cloud on Kubernetes. So why Elastic Cloud? What is this? And you might get that out. But before getting into that, I need to do a bit of pre-intro to intro, because that helps you to set some context. You might have a question like, what is Kubernetes? I know Kamesh and several other speakers have done quite a bit of stuff on Kubernetes. I also see Abhishek or everyone who is speaking today would definitely have Kubernetes in their slides. But I just want to give an intro. If you are very interested, I'll quickly go through it. So basically, Kubernetes is a container orchestration system. You have nodes, you have pods contain again containers, fleet of nodes, etc. And then how do you access containers? You access pods. Actually, you don't access directly containers which are running your apps. You just use your service methodology to connect to a container and then start bringing in this stuff actually. So that is a way to look at things. And then you can TCP your create a TCP socket and start routing all the network traffic that is coming from outside to you through your service to your container, and container will respond to whatever thing. And then there are many other things that people generally don't mention. Kubernetes has a secret store. Secret store is like store that everyone need to know, but it is a secret store. So where you can store important credentials or important things that you need to store with respect to your application, like some important environment variables. So secret store is some other thing that you should definitely take a look at. And then you also have volumes through which you can connect to the data. You can also upload, you can also connect your NAS, network assisted storages, that you can attach to your pods, and like you can serve it, like you can increase, decrease. There are interesting projects in this area called OpenEBS, etc., which are quite useful. And many more resources exist. So there are deployments, replica sets, then there are daemon sets, which are on every pod. Then there is persistent volume, which is a concept that, like, can be reattached to different pods. Like you want to restart the compute, but you still have the same data being attached. Like it's just like a pen drive that's getting attached. A very wrong example probably, but then still it sounds good. Then you also have stateful sets, which is a core area here today if we are looking at. So stateful sets are something that has made a bit of, like a lot more changes in the ecosystem of Kubernetes, because that helped to do a lot of distributed systems to run on, data systems to run on Kubernetes. So earlier Kubernetes was like a stateless system wherein you can run apps, but you can't run something like a system like a database, or like MySQL, Oracle, or Elasticsearch, which is a distributed system which shares data in between them, and then which needs to communicate between containers, pods, and a lot of these. So stateful sets helps you to do all of that much easily, using, again, with persistent volumes, etc. So, and again, when we talk about all these resources in Kubernetes, again, sorry for the small letters, but then like I want to put everything here. So then you also have pods, services, secrets. Everything is a declarative way. It is a YAML file, and the YAML goes to an API server as an instruction, and then like it has a certain structure. Of course, it's really difficult writing YAML. To me as a developer, I feel really difficult, but then like it is very interesting and useful for you to mention the important infrastructure details, and then like you can push the data, and like you can create all of these resources. So these are some examples, and you can put everything in one single YAML and run it, or you can do separate YAMLs to each resource, each component actually. And talking about Kubernetes architecture quickly, again, we spoke about how Kubernetes internally work, but how do you architect this entire container orchestration system? There are many good. I recommend you to use definitely something like OpenShift if you are going on-prem, or like if you are using a cloud platform, you should definitely think of using a managed service, because Kubernetes is really large. It's a great platform. It's a huge platform. Anyway, so, and there are multiple components, like I say here. See, for example, you have all these components, say something like etcd cluster, which is a key value store, which stores all your metadata about your API server, and a lot of this state management, etc., happens to etcd. There is something called reconciliation loops. There are many thing involved in running this software. Kubernetes itself is a software run in Golang actually. Then you have API server, which helps you to kind of like, which is like a server which takes all the API requests and like completes that request and returns to the user what's happening in the system. Then you also have user. Obviously there should be a user, and then like which orchestrates this thing, and which can which queries through HTTP API, and often with kubectl, which is a popular CLI tool. Then you have kubelets, which is running on each of these node and helps you watch the pods, health of the system, and many other things. So kubelet, kubeadm, there are multiple things. Kubernetes is a vast ocean. We are only scratching the top today. Then you also have controllers, which is very important for today's topic, because these are the controllers which controls your resources in your Kubernetes ecosystem. So if I have to tell you, it watches the resources in the API server, how it is working. Like I said, there is a reconciliation loop, like a regular while true loop, which will run through your resources and see everything is proper or not. And then like it interacts with your like kind of a controller is the one that helps you to do a lot of these things. There are some existing controllers which are inbuilt, like system controllers, which are schedulers, replication controller, ensuring that suppose if a container is lost, or like if container dies or killed, then it automatically spins up a new container to equalize like the replica count that you have put up. So you are treating the infrastructure like a cattle rather than like a pet, and you are able to scale up, scale down the services much easily. So there are multiple other controllers like which are systems which are interesting, and all the logic is again open source. You can go and take inspiration from anything and you can write. But by this time you might feel like, okay, I know Kubernetes, I like everything, let us deploy applications. But then like as we speak, Kubernetes is not so easy again to deploy applications. There are much more complexities in managing applications itself. So how do you bring in that to this and still leverage all the pros or the important positives of Kubernetes? So then you got something called Helm. Helm is a package manager used for Kubernetes. Of course, when Helm was launched, several community members have contributed Helm charts, which is like a package to deploy application, more used for your CI/CD deployments and your versioning changes, etc. It's more of like, I would say it's more of like NPM, which manages your node packages, where node itself is a framework, and then NPM is a package manager, which is talking about all of this. So it's something like that, not exactly similar, but something like that. But Helm is also limited, and it can only deploy, it can do other many things. And then like Core OS introduced this operator framework. So operator framework, basically what it does is like it helps you to deploy a resource and create some steps. For example, if you are deploying a database, what you want from a database: the database should be up all the time, the database should be consistent, like it should not have any problems. The database should like give power to all the users that are talking to it, like ensuring that the connection pool is enough. There is no transaction, huge transaction log, long running queries, and several data related issues. So this is just about database. Thinking about distributed system like Elasticsearch, you have many other things like ensuring the data flows freely between the pods. Then you have some certain mechanisms that you want to check regularly, whether if a node is gone, you want to bring up another node, which is container in Kubernetes terminology. So you're managing this huge Elasticsearch cluster in a Kubernetes ecosystem like containers, and still want to organize like everything much easily. So talking about the Helm versus operator, like people might have confusion between operators and Helm. So if you think of like something like an operating system, the package manager sits somewhere here. And if you think of like Helm versus operator, then you could see that where operator sits in. Operators is something that is more tied to application centric logic. Helm is more of like a package manager which holds everything and deploys it. But there can also multiple versions of operator or versions of software running in this operator. So that is also an interesting thing. And there are, I really don't want to confuse you more. I just quickly want to like show you where all this resides. If you are least bothered about how this works, but you only want to see how to deploy, how to run stuff, then you just head out to Operator Hub. There are a bunch of operators here, and Elastic Cloud on Kubernetes is one such thing. And the code is open source. You can go and look at that. So what basically, like, this is the pre-intro, and this is the intro that I want to talk about. So we have created a custom resource definition, which is the controller, that special controllers or bunch of controllers, which is a resource that we have created, and that is being supplied like in a YAML file to you for you to deploy. And then this custom resource definition contains Elasticsearch, Kibana, APM, and host of other stack services. That so don't think that I don't have beats. Oh, I don't have Logstash. No, all of them are there as a containers, but we think that there are certain important concepts that we want to orchestrate and make sure that it's available all the time through the operator. So Elasticsearch, Kibana, and APM are chosen, and there is a reason for. I'll show you. You can still run a lot of good stuff using these three, and then like a set of controllers. Obviously, like I spoke about it. More importantly, when you deploy Elasticsearch or the stack on top of Kubernetes, you literally get everything secured. You don't need to do anything. Literally anything. You get a password store, you get TLS encryption between the nodes automatically created, you get a service to access the cluster, you can use the preferred load balancer to expose it to the outside world, still secure. You just need to use a password, create RBAC users, like, and set permissions, etc. Deployment templates like hot form architecture, orchestrating with the different pod templates. All of this can be done, and all free and open. So you might feel like, okay, Aravind, you have rushed to the slides. That's it. And do I have a demo? Yes, definitely. So we'll quickly get through the demo. I hope the deployment is complete. Thank God. So let me quickly go back. So, and I have not to make any mistakes. So what I have is like, I also have this, the session so that I can like all the commands easily. So just let me quickly connect to the cluster. I believe the client name is different. Okay. let us go to the home, Kubernetes service, then cc-demo, that's what we are looking at. And then this is a Azure shell that I have, and then like I am using that to like demonstrate this to you. You can also use Azure SDK to kind of like use it on your own custom thing. So now that we are connected to the cluster, and then I have a backup cluster in case if things don't work, and we could still work things. So okay, so I don't have anything related to Elasticsearch, so I should not execute this command, but this is the operator installation command. So you see that I am downloading something from one YAML file, something from here, and then I'm trying to show everything easily. So let me create this and also like see if I could increase the font size so that you all.
Sorry to interrupt you, Arvind. Like, could you please like share the link because people are asking for
Which link?
this demo link if the code sample is there already.
So I haven't put up anywhere. It's there on the documentation in
Okay.
the first hand. But once if we see all of this, and then like I will definitely share you the link so that you can go and try it anywhere. And all of this
Sure.
is there. So if you want to parallelly execute, I don't think it's the right moment because I believe that this is a tricky time. I might be showing multiple stuff.
Okay.
Um, what I just did is like I looked at the logs, stateful set apps and Elasticsearch operator logs, and then like a bunch of logs and other stuff, and then to see how the operator is performing, and then I'll just simply deploy an Elasticsearch cluster here. So I have created this ECK, Elastic Cloud on Kubernetes Service Platform, and then I have downloaded it and I created this cluster using this one YAML file. So what I'm doing, the node is everything. I have some system settings, I have some app search related settings. I used the load balancer as a type, version, name. I have given quick start. Like that's it, done. And if I create that, it simply creates a pod. Obviously, the cluster is being created. Let me see. I know it is kubectl get pods, and more importantly, you can do this thing as well. Get Elasticsearch. So why it is like a command? Because the reason is we are deployed a custom resource. So Elasticsearch is a resource inside your Kubernetes. So that is one another thing to look at. So
Uh,
anything, yeah,
Arvind, could you please just increase the font size or the
correct.
screen?
Yes, I will
Sure.
try to do that. I generally try to do that, but this today it is really bad actually.
I
I
think it
believe
will.
this is better. This is
Sure.
better.
Yeah. Thanks.
So we can continue watching this pod. It takes a while to apply changes and get things done because the containers needs to be get up and like start running. Say it is still showing in it, but then I'll cover other stuff as well. So you could also take a look at like the commands like you can see logs from the pods, which is a regular kubectl command. I have kubectl get service, so we could also query the service. The password when you deploy this cluster, it's automatically configured with TLS and also the security, and it automatically generates one user and password. So there is an Elastic user. The username is Elastic, and the password is some base64 encoded string. And then you just run this command, and from the secret store, the data comes, and the password can be retrieved using that. So it takes a while sometimes. I don't know why, but generally it takes a while. So we'll quickly go through the commands meanwhile. So then you also have you can curl it and see with the IP address. I have deployed a load balancer if you see here, and then I have like which will get us the external IP, like the public IP address. And then once that is done, and then we can quickly go to the Kibana and see the results actually. So let me see if it doesn't come here. Okay, it's running great. If I see that health still unknown, applying changes because it might need to deploy something else based on that. But we'll go ahead and see. We'll go ahead and run some stuff. So now that we have deployed that, we can see the pod logs using this thing. It's deployed as quick start es -default -0, and then you will see the logs. Like you could see that the basic security is enabled and node ID policies, etc., etc. So let me quickly come back and show you something else. Meanwhile, I believe that the cluster is up and running, and we could also see the service. Yeah, so you got an external IP. Go ahead and try this IP. You will not be able to log in because I have the password. So what we'll do is like we'll put this password into this, the store, but we definitely need this password. So I mean, like for using some other for some other related details. So if I use it, okay, sorry, I did make a mistake. Copy C. So if you see that it is a base64 encoded string that you have here, and then we could quickly use that. I'll not demo it because we don't have time. So you could quickly do a curl or do something, and then it simply works. Now quickly getting into the Kibana, because anyway Kibana, we'll show Kibana UI. Anyway Kibana like comes up to be like, easy to kind of run the stuff here. So specifically Kibana was created, and then like it is attached to a quick start instance of Elasticsearch. So it's paired automatically. Just see that the beauty here is you are not really working on anything crazy. You are just using YAML files to automate everything, and things automatically work and gets running up. I'll also talk about the complexity here. The reason being, as though it looks really cool, but there are complexities everywhere, and I also want to, I believe in explaining that as well. I don't want to like say, okay, it is very easy, you just need to jump the bus and do this. There are things that you need to consider as a Kubernetes as a service, not managed service, but generally Kubernetes as a platform. There are a lot of things that you need to manage. So that is why if you want to go to a software, probably a better managed service might be much easier. So still container creating, we can go ahead and see what is search UI. So basically once this comes up and once I could log into the Kibana, so what I'll show you is like I have an open source project called search UI. And basically what it does is it's a UI library written in React, which can connect to Elasticsearch instance and query the data and show you something unique. So I have this Elasticsearch example, and then what I'll do is like I'll simply open up, use the same username password and like kind of query that. So let me show you that. Great. Okay, it's running. So kubectl get Kibana. You get this. It's still showing red, but it will take some time to do that. If you want to see all the services SVC, you'll be able to see this. Where is our Kibana? KB is Kibana. So this is our IP. So if you go here, okay, you need to copy this. So you run HTTPS, yes, and then like you do this and 5601, and then like you click on this. It should open this because I have a self-signed certificate and it shows not secure. But for the demo purpose, I didn't add my certificate. You can generate a certificate and do stuff. So it asks me a password, and then I should roll back or like run the previous command to get the password, right? Obviously. Let me, yes. So I have the password. So this is Elasticsearch password. This is the password that we generated along with the cluster. So if I click here, I get this, and I need to do this stuff. And when I give this, it should automatically log in and show me the screen. While this is coming up, we'll also see whether what's happening with Kibana again, like whether it is red, why it is red, health, yeah, it's green. So all of this is come, explore on my own. Then there are a bunch of things. It's a natural Kibana, and you can do all of that. While not wasting time, I'll quickly go and insert some data so that we can get started with the search UI, and we build a search engine. So my goal here is to like create everything in a little bit of time. And so I have this data. So this is just national park data. Have 60 documents roughly, and then like I'm using the bulk API to ingest the data. The data has been ingested, everything has been done. You could see the get underscore cat indices. I'm going a bit fast because of the time. I believe I'm not doing great on the time, but yeah. So national parks, yeah, 60 documents. Now what's so fun? Like I said, I cloned the project. here the same example UI project. And now what I'll do is like I will use this particular, so this is a way that you run this particular thing. I'll just use that, and we need to give the password and the IP that we used there. So let me quickly go back and collect the password. Okay, password is, oh shit. Let me quickly open that host HOST. Yes, correct. So now I have this. We should not have this particular thing. And Command C so that I don't miss that. And run it. Great. Then it's just a React.js project. And I need to give the Elasticsearch UI so that the data is stored in Elasticsearch. So that's the storage engine for us. So, and then give that, and then click enter, and it just compiles, builds, and like shows you runs on localhost 3000, and opens that. And then you get a search bar with an empty page. And then when you click search, it should connect to that particular index and show you the stuff. So all that we have seen, we have built a search engine on Kubernetes using Elasticsearch, and then we have used another open source project to connect to it, and then do all of that. Now I think without delaying, I mean, I'll do one more trick, and I'll show you almost. I hope it does work. So let me come back to this particular area. So I also have APM. So you could also use APM in Elasticsearch to run on Kubernetes to run and do all of this stuff. So I'll just create that, and then I'll trace an app. I'll show you how to trace an app. And again, you have this entire secrets related to APM is stored in a specific place. Again, the secret store. So I am just using that to show you the token. So while this gets created, it's already created, but while this gets created, I'll quickly show you that the app that I have, and then we can get started. So I have another Spring Boot app which is in this specific location, and which is a Java app, and which is just Docker and everything, which can also be pushed to ACR, etc. We are not doing right now. I just have my one target, and I can run that target and ship that stuff. But before that, I want to showcase you that this particular like there are some settings that you need to mention, that how do you configure this APM agent. So I have already a previous agent that I have configured. So we just need to give that APM the username, password, and then kubectl get APM. So, and then you have this screen. Great. So then again, do this kubectl get SVC, the services, so that we get the IP related to that. And then you have APM service quick start, external IP. See, you can use all your VPCs, everything to do all the stuff. So no questions asked. So this is just a demo. So that's why I'm skipping a lot of stuff and not showing anything here. So I have that, and then I have the secret token, which I definitely need to use. I think I messed up and I didn't copy that properly. So I have that. Let me copy the secret token, Control C, then B. I made the certificate verification false, otherwise it will fail. Just do this, and then like come back. And so this is basic simple Spring Boot app I'm just trying to run. And one more thing that I want to show you here is I don't have any data in the APM part, but again, let me run it and then I'll show you. It takes time. So yeah, Spring Boot run, and then if you see that, it should say that it is attaching to the agent that we have shipped here. Yeah, see. So what we are trying to do is like trace an Java app. We have built a search. We also want to do observability, and we want to connect to a service. So that's what is happening here. You could see that the agents are being connected while the data is being shipped. I'll show you quickly here, and this is my last demo. So I'll show you some stuff here, and then we can take questions, or I'll share you references as well. So in the last 15 minutes, and see that if something comes up, like say refresh it for every 1 second. it should start showing up. Meanwhile, we can also open localhost 8080. That's where the app is running. It's not still up. Yeah, started application. Yeah, it has come up, and then it's a simple app. And then I have demonstrated this app in like bunch of demos recently. So I have a custom generated error when I'm trying to log in with admin, etc. So all this is done. Now you see that the data tracing has been already started. If there are errors, we just generated an error a few seconds ago, and then all this being happening. So all of this happening on Kubernetes, and we have built just now. We have created all of this in just this last 40-50 minutes. So yeah, you could do a lot more using this particular stuff. And I think I mean, this itself is like a lot of learning, a lot of data dump that on you. So we could still do more, but I think like I'll go back to the slides and show you some information. So if you are looking to join for more of these demo sessions or things, please join us to community.elastic.co, choose your chapter, or even like please choose the virtual chapter. We are doing virtual meetups. So APAC virtual chapter, join there, and we will do that. More resources, ECK-K8s. One more thing that I want to tell you here is I also have a guides platform where I'm writing all of this like a guide. So if you want to get started with the building a search engine, or building a observability platform on Kubernetes, or doing anything related to cloud native, I'm going to put a tutorial here regarding this. I already have it, but I want to push that out. I couldn't do that. I'll do that, and then you could get to stuff. So any questions, anything that people want to ask? Sorry, I rushed through a lot, but yeah, I think it's important.